Right, this is a familiar topology for us. In the previous class, we did static route, IPv6 static routing. We saw how to write default route and static routes. And today we are going to remove all those static routes. We are going to replace it with routing protocol. On router 1, I remember I gave a default route. We can check it by typing show run section IPv6 route. Show IPv6 route. Looks like I did not save. Good for us. Okay, likewise, let me check it on router 2. Show run section IPv6 route. Good, I don't see anywhere. Show IPv6 route. There is no route in the routing table statically assigned. Let me check routing table first. Show IPv6 route. Aha, this one has got a static route. Let's remove it. We got it removed and now verify it. Show IPv6 route. There is no IPv6 route. Now let's go to router 4. No. Likewise, I'll check it on the other two router by pasting this. Okay, no IPv6 routes. What is next? Let's learn RIP protocol. I don't think I have configured 4 and 5. I think we configured only IP address.
We configured till 4 back to 1.
Yeah.
4
So
till 6.
let us also add 5 and 6 today because we need to do EBGP, IPGP. We need big topology. So IPv6 address is going to be F. Okay. So router 5 IPv6 address 1:E/128. We got the addresses. Show IPv6 route. The route should be there. And if I ping the directly connected adjacent router, which is 2000 DE4, I'm pinging. Not even a single packet lost. Let's go to router 6. Let's ping 2000 colon EF colon 5. All right. So this proves that we have the reachability to the adjacent router. Now, what is next is we need a routing protocol to ping remote networks, which is not currently possible. You see, when I try to ping 1 colon D, I'm not able to ping. Oh, the other reason is we have not enabled IPv6 routing. Enable IPv6 routing. Come on. IPv6 unicast routing. Now try to ping the same address which I was trying to ping. It says no, there is no route, no valid route to the destination. Okay, on R5 also I have to give this command IPv6 unicast routing. See, without this command you cannot traverse the packet. You cannot pass the packet through the router. So if router 5 needs to take the packet from 6 and give it to 4, R5 needs to be an IPv6 routing enabled device. So this is the command that we put to enable routing. Now we are in router 6 to enable RIP. Very easy, but I wish to have an IPv4 address. Pay attention. I'm having an IPv4 address. This address I am not going to use. Only on loopbacks on every router I'm going to have an IPv6 address. I'm not going to use for reaching any device with this address. Then why do I have this address? If I'm not going to use it for reaching any device, why do I need it? I need this so that this will be picked as a router ID by IPv6 protocols. The IPv6 routing protocols, they need an IPv4 address. Actually, it's not an IPv4 address. They need a 32-bit address, same like IPv4 address. So what I do is, instead of me configuring router ID manually for every routing protocol, I just leave it there in the loopback interface. That is going to be taken by whatsoever the routing protocol that I'm going to configure. All routing protocols need router ID. Now you remember we already have IPv6 address in the loopback, but you also notice that I'm giving an IPv4 address on the same interface. Is that okay? Of course, absolutely okay. You can very well have both IPv4 and IPv6 on the same interface. You see, show run interface loopback 0. You will see both IPv4 and IPv6. When you type show IP interface brief, you will see only IPv4 address. When you type show IPv6 interface brief, you will see only IPv6 address. But it's the same loopback interface. I can say different controller for here. 4 and 6. What is next? I would like to also add here. Then. So we got things in place. Let us now enable RIP protocol. I already told you, if you don't have this command, you cannot even enable routing protocol. You want to see that? Let me let me disable this. No IPv6 unicast routing. I have disabled it. Now I'm trying to enable RIP. See what happens. I say interface F0/0. This is the way that you enable IPv6 RIP. Go to the interface straight away and say IPv6 RIP. Give any name. Give any name like September. Enable. But you see, when I say this one, it says you have not enabled. The enable is not said, so it is incomplete. But when I complete this, it says no, still not okay because IPv6 routing is not enabled. You remember I disabled this IPv6 routing. That is why. When I put this command and then go back to the interface again, and I say September enable, now it gets enabled. Let us also enable it on loopback. Okay, IPv6 RIP, a process ID. It can be a number or a name. I've given name as September. Customer is going to be October and enabled. Let us verify. Show IPv6 protocol. You can see here the protocol called RIP running on these two interfaces. This is directly connected. This is neighbor discovery. Neighbors are discovered using link local. They are all running by default. Now I have enabled RIP. Let me also enable it on R5's other interface. There is another interface on R5, F01. So R5 has got three interfaces. We should have three interfaces running RIP. NG. We call it as a RIP next generation, RIP NG. You can also type this command show IPv6 RIP process. RIP database, okay, database. Okay, so far no database is built because we did not learn anything from any neighbor. Okay, when I type this command, it looks like IPv4 output, you see. Show IPv6 RIP and the process ID, it says port number 521. You see, 520 is the port number IPv4 RIP uses. IPv4 RIP uses 520. IPv6 RIP uses 521. And the multicast address.
The UDP port.
Yeah, UDP port, correct. UDP port, very well said. UDP. And the multicast address that RIP uses is FF02::9. Administrative distance is 120. The maximum infinite metric maximum path is 16 hops. Updates are sent every 60 seconds. These all are same like before. In IPv4, whatever you learned before, it's same. Now let us go to R6 and enable. We already have IPv6 unicast routing enabled, so I can go straight away to interface range loopback 0, comma F0/0, IPv6 RIP. There I gave September, here I can give October. Enable. That's it. Now on R4, router, no need. Interface range, F0/1, comma loopback 0. See, I'm not going to run RIP on F00. Why? We had enough of RIP. We are going to have EIGRP in this direction and we'll redistribute IPv6 RIP August. Oh, IPv6 routing is not enabled. It's okay, we'll do it now. IPv6 unicast routing interface F0/1 IPv6 address 2000:DE::4. This is missing. Okay, now IPv6 RIP August enable. Got enabled. So I have enabled RIP only on F01 and loopback 0. By this time I should have roots in the routing table. I told you the link local address will be used for neighbor discovery. Even the routing protocol uses that link local address in order to discover neighbor. But we know RIP never discovers neighbor. Do we have any neighbor table in RIP? No. But link local address is used in order to share updates. Let's verify that. Show IPv6 route here. You can see routes, but learned from via what? What? Via what? Link local address. It says I have learned these two loopback interface networks of R6 and R5 via link local address. You know whose link local address is this? It's the next hop link local address. Who is next hop? Router 5 F00. Let's go to F00 of router 5 and verify. Show IPv6 interface brief. Go to F00 and see the link local address. You see it is ending with 5D8, okay? 5D8. You see 5D8. So the next hop address is not going to be a global unicast address. It's going to be link local address. So link local address is used for neighbor discovery by the routing protocols, and that is the address which is going to be used to share the updates. If you debug and see, you can see packets coming from link local address, RIP updates. You see, it is received from link local address, but the destination address is multicast address FF02::2. It is learning these prefixes with hop count metric. Yeah, let's stop this. So we have RIP, and I can ping from router 4, I can ping router 6. Router 6 is 1::F. I'm able to ping because we got route. Now on the other side, we are going to enable EIGRP. So we got RIP here. We got RIP. Here we are going to have EIGRP. And we'll do redistribution between these two. MNR4 EIGRP is something special, I can say. There are two ways of configuring EIGRP. Listen to me carefully. I'm going to do on R4 classical way. IPv6 router EIGRP 100. Autonomous system number is 100. See, I'm using the command what? IPv6 router EIGRP. You need to pay attention to this. Yes, I'm not going to use the same command on the other routers. On the other router, I'm going to use the newer method. This is older method. All right, and I'm going to say, listen carefully. I'm going to say no shutdown. Yes. There's nothing more you have to do here in the older method. You need to now go to straightaway interface F00 and say IPv6 EIGRP 100. Boom. That's all. This is old method. EIGRP is running. You want to see that? I'll show you. Show IPv6 protocol. You see? You got EIGRP version IPv6 in autonomous system 100. K value same like before. K1, K3. How many Ks you see here? 5 Ks.
5 case.
Okay, I have a reason why I'm asking this. Later you will understand. You see, I did not give router ID. It is automatically picked from the loopback interface. All right. Now, only very important thing that you should remember is you should say no shutdown. I have already did it. Now let me go to router 3. Even in router 3, let me use the older method. Okay. Let us do older method in router 3 also, so that you will have more clarity. IPv6 router EIGRP 100. Okay, IPv6 unicast routing, IPv6 router EIGRP 100. No shit, nothing I give. Okay, now I need to go to the interfaces. IPv6 EIGRP 100 finished. So you will see neighbor now. See, neighbor again. EIGRP uses what? A link local address to discover neighbor. So it's not using your 2000 address. Your 2000 address is for you to use. For machines to, for routers to know each other, they use their own link local neighbor discovery address. They don't disturb your address. Now let us check show IPv6 protocol EIGRP. Show IPv6 router. Show IPv6 route EIGRP. No routes are linked because this is directly connected, but on R4 I should see some routes. Show IPv6 route EIGRP. I'll see the route from Lubeck router 3. You see, this is Lubeck of router 3. And this is the network between router 2 and 3. Okay, now let us go to router 2 and enable EIGRP using newer method. How to do that? You don't need to say IPv6 router. You say simply router EIGRP. Give any name or number, just a process ID. This is not going to be autonomous system number. Earlier, when you type 100, it is autonomous system number. But here I'm going to give a name. I'm going to give a name as Feb. Hi, fib. And then address family, IPv6, autonomous system number 100. See, this is the way you do it, but I did not type this command, IPv6 unicast. Okay, now let's do again. Okay, you see, as soon as I say that, I can see neighbor established via F01. But anywhere in the above, did I enable EIGRP and F01? No. Let's verify. Show IPv6 EIGRP interfaces. Look at this. That's the beauty of newer method. Wherever IPv6 is running, it will now run IPv6 EIGRP. You did not see me going under any interface like I did in the older method. In the older method, I was going under the interface, you remember? But in the newer method, it is simple. I say router EIGRP, process ID, and then I say address family IPv for autonomous system 100. So wherever IPv6 is running, it made as a member of autonomous system 100. If you want, you can see again, show run section interface or show run interface F0/1. Did I put any EIGRP command here? No. Now, if I say show run section router EIGRP 100 whatever. Let's see. You see, I did not mention any interface anywhere. Okay, so that's the very important difference. I'll also go to router 1 and do the same. IPv6 unicast routing command, very important. And then router EIGRP, there I gave February, here I am going to give Jan. Address family IPv6, autonomous system.
Sir, IPv6.
Sorry. That's why I was wondering why it didn't come. That's it. So easy. Now,
Sir, but if it is automatically taking all the interfaces in IPv6, then but if we need any other interface to be running OSPF or etc.,
then you can go and disable that on the command. Say like this: router EIGRPGen. I gave this command. Go inside, and if you will see the address family interfaces and
passive something like that.
Interface, let's say F0/0. No, this is by default. You need to say no address family interface F. So this removes EIGRB from there.
Okay.
It's not a member. I just want to check whether it works. There is also passive interface. I will take you there, but before that, I'm checking this. Do show IPv6 EIGRP interface brief, interface. Oh, it still runs. So that's not the command. Don't use that command. There is a topology base command. Topology base. You go inside here, you will see that passive. Actually, it should be under topology base. So the question is, if I don't want to run EIGRP on one specific interface, what should I do? So
Do we need to go to the interface and?
Yeah, that is also a nice way. Wonderful, good idea. Go to interface and say no IPv6 EIGRP. Should I give process ID or okay, autonomous system? That's it. This is a nice idea. Let's verify now. Show IPv6 EIGRP interfaces. No, it still runs. Come on. There should be some way to filter it out. Oh, I don't want any of this. I'm confusing the router. Let me remove the EIGRP and put it back because I have made a lot of mess. Show run section route. Okay, I removed it. Now,
Or is it like if the device needs to be having all the interfaces running EIGRP, then we have to give it in this way? And
otherwise in the classical way. Yeah, that is also you can follow. But there should be some way here itself. Okay, wait a minute. I want to discover router EIGRP gen. Okay, everything is under the address family. This is related to topology. It must be in topology, but I don't see the command that I'm looking for. EIGRP. Okay, there is a keyword stub that can also be used stub receive only. Okay, this is for logging only. Okay, I'll also check. You will also check. Okay, let me know when you find it. I'll also know when I find it. There should be definitely the passive interface related equivalent command in IPv6 version. There cannot be a protocol without that. Okay, so please check from your side. I'll also check. Now we need to do redistribution between RIP and EIGRP on router 4. Before that, 5 minutes break. 5 minutes. We're going to redistribute from RIP NG to IPv6 EIGRP. I'll go to router 6. In router 6, now we use the older method. I'm going to remove the older method because in older method, you know very well how to do redistribution. But I'm going to show you newer method so that will be a learning. Hey, come on, what am I doing? Not in R6, R3, no, on R4.
R3 or R4, sir?
R4. R4, I'm going to remove the older method because in older method it's a normal redistribution command. Now we lost neighbor. Now let us put this IPv6 router EIGRP April address family IPv6 autonomous system 100 and then you need to go to topology base command. Topology base redistribute. Wait, before that, why the neighborship has not come between 4 and 3? Show IPv6 EIGRP interfaces. Okay, because I removed the older one, no? The newer one is not enabled globally unless you specify the interface. So I'm going to say oh, I said IPv4, that's why. No, okay, sorry. I made IPv4. Otherwise the neighbor would have come. Okay, neighbor has come. See, you need to go to topology base command in order to say redistribute RIP. We gave some name for RIP here. Let me go and check the name. Show IPv6 protocol. The name for RIP that I gave is August. So going back to EIGRP, topology base, redistribute RIP, August, metric. For all the RIP networks, what is the metric that I want to give? Metric should be in K values. First bandwidth, I'm going to say 1000. Delay, I'm going to say 10 microsecond. Reliability, 255. Load, I'm going to say 10. MTU, I'm going to say 1000. Okay. So include connected. We'll include the connected networks, not only the learned networks. I would like to say that one as well. Boom. What I'm expecting is on R1, the RIP routes. Show IPv6 route EIGR. You see, these are all RIP routes, external. E and F is what? Router 5 and router 6. external, 170 administrative distance. For EIGRP's internal network, it is 90. Likewise, on RIP, if I want to see.
Sir, one doubt.
Mm-hmm.
1::: D in R4, that was also in RIP only, right?
1::: D, but I say
D.
connected, no? D, we put in EIGR, sorry, we put in RIP, I do agree, but administrative distance of EIGRP is lower, right? And I have enabled newer method. It runs on all interface. Yes or no?
Okay. Mm-hmm.
That's why.
Okay.
Now, we don't see those EIGRP routes in RIP. The reason is we have not done the other way redistribution. Let's do that. IPv6 router RIP. What name I gave?
August, I think so.
Yeah, just now we used for redistribution.
Yeah,
Okay.
AUG.
Yeah.
Here redistribute EIGRP 100 include connected metric some hop counts. I'm going to say 5 hops. As a result, on R6, if we check the routing table, show IPv6 route RIP. I'm learning all the network routes. So I'm able to ping now 1:A from my source loopback 1::F. Yeah, that's it. So we got RIP, we got EIGRP, we got redistribution. Now I'm going to do BGP. Between R1 and R6, I'm going to do IBGP. Between R1 and R6, I'm going to do IBGP. You see, router BGP autonomous system number, I want to use 10. Very simple. Neighbor is 1::A. Remote AS is 10. See, same like IPv4. After saying this, you say address family IPv6 unicast, and then neighbor 1::A activate. You need to activate the neighbor under IPv6. But because you are using loopback, you also don't forget that IPv4 rules. Update source, loopback 0 is mandatory. So let me show you what I have done. Show run section router BGP. This is what we have done. In IPv4, you don't need to activate. So it is there by default, saying, I did not say this, it is there by default. I just went to IPv6 and activated it. If you want, you can cancel this. You can cancel this if you want. I can show you that also. That's it. You see, looking very decent, much better. Oh, what happened? The neighbor is gone. Only activate command is there. Let me check. Show IPv6 BGP. Show BGP. Show BGP. Show BGP.
IPBGP summary, right? IPv6 BGP summary.
That command won't work. Show BGP.
Address
IPv6 unicast summary. Okay, it's idle. Okay, so now let us go to router 1 and configure router BGP. According to me, what we have in IPv6 is not okay. It says autonomous system 10. Then okay. But neighbor, okay, neighbor is also an autonomous system. Then okay. But in the output, it didn't show no. Where is the remote AS command in output? Okay, it has come back. It generates automatically. So forget it. No, don't remove this thing. Let it be there. Okay. Now that's operating system syntax. So let us now say what we necessarily need to say. 1::F remote AS and then activate. That's it. You will see neighbor coming up shortly. See, the neighbor has come up, and you see the neighbor address 1::F. Show BGP IPv6 unicast summary. Now let us advertise some network from R6. On R6, I'm going to say interface loopback 66, IPv6 address 111122223334445555/128. And I would like to advertise this network under BGP. Router BGP 10. Address family IPv6 unicast network. So it should be under the address family. Don't forget.
Okay.
Now on R1, if you go back, earlier it was only 0 prefix received, but now 1 prefix received. And if you type this command without summary, show BGP IPv6 unicast, you can see that one network. And you see it is having the next hop of router 6. And in the routing table also you can see show IPv6 route BGP. So we have seen OSPF, we have seen EIGRP. Sorry. We have seen RIP, we have seen EIGRP, we have seen BGP. Now next class we'll see ISIS and OSPF. What do you say? Okay. OSPF now itself. I'll remove this routing protocol whatsoever running. I'm going to remove by typing no IPv6 unicast routing. This removes all routing protocol. I'll put this on all the routers. Because we got just one routing protocol to finish this topic, let us finish this. And it is not easy, it is not difficult, it's very easy. OSPF is the easiest configuration in IPv6. Right, on first 4 routers we are going to do show IPv6 protocol. You don't see any protocol. IPv6 unicast routing. Now given this command, see there is no protocol now. We are going to enable OSPF. Before that, I would like to put this command IPv6 unicast routing on all other routers. Now, we are on R4. Need to enable OSPF here. It's very straightforward. Go straight to the interface. Interface range loopback 0, F0/0 -1 IPv6 OSPF process ID area ID. That's all. Same like IPv4. Now if you see show IPv6 protocol, you can see here OSPF running with the router ID on all these 3 interface. Easy, no? So I'm going to repeat the
Yes, sir.
same.
Classic type.
What did you say?
The classic type is sir.
No, we don't have classical way of configuring OSPF. No wildcard, nothing
Okay.
like that. Only like this. All right. So I'm going to do what? Do show history, and I'll copy this.
Sir, upon the OSPF specific commands irukilla sir, timer adjust பண்றது
That you need to go to router OSPF. I'll show you that also. See, the neighbor has come. Here the router ID is used, but link local address is what actually behind the screen. Show IPv6 route. You see, what is actually behind the screen is link local address. Even though the neighbor is shown as router ID, but it is not the router ID that is used for communication. It is just an ID. The communication address is only the link local address. Now, let me also configure OSPF on. Girish, I'm coming to your answer question later. Give me some time. Let's finish this configuration OSPF. All right, and R1 also, let me enable OSPF. Now I should be pinging from here to router 4. Ping.
There's an incomplete command.
What is that? Okay, there is no interface 1/. It's okay. We don't have interface, this interface on router 1. That's okay. Now, if I ping now one, okay, neighbor has not come. No, show IPv6 OSPF neighbor. It's in two-way state. Okay, we need to wait. Okay, now if you see, I will be able to ping 1::D with the source 1::A. OSPF is over. Now, if you are changing any timers on, you need to go here, router OSPF, IPv6 router OSPF 1, IPv6 router, okay? And you will see all those timers and metrics and all those stuff. All right.
Okay, sir.
Fine then. We stop